Hello and welcome back to Compiler Programming. What I thought to do today is change up the pace a bit from all the parsing business that was happening in previous episode and go back to working on some of the more primitive operations that we are dealing with. And in particular, what I want to do is what's called constant folding. And the basic idea is pretty straightforward, that when you have something in a compiler where you know the result of operation, you should just go ahead and do that operation at compile time rather than pushing it all the way to runtime and having a runtime cost for that operation. So for example, if I write 12 plus 1 even in C, what's going to happen is the compiler will actually look at that, know that it's 13, and go ahead and put 13 as a number directly. And right now that is just not the case with our code. So it's time to fix that. Should be pretty straightforward. In here in value.c we have this nice helper called operand is immediate. And basically all we need to do is to just try to check that if operand is immediate of a operand and operand is immediate of b operand, we actually go ahead and do the operation. Now the only tricky part is that we should always consider the immediate to be like to ensure the correct size, basically. Depending on it doesn't matter what this original size is, we'll kind of do the operation with the maximum precision that we have, so 64 bits, and then same as when we originally create the immediate, we will just try to shrink it down to whatever is the right size for it. At least that's the plan. I'm not sure if there are some hidden cases I'm not thinking about. There is definitely stuff around unsigned numbers, but we don't support them anywhere in this compiler anyway for now, so that's just a thing that has to be taken care of separately anyway. So for now I'm just dealing with signed numbers. Okay. One thing that probably I want to do is we have these nice functions in immediate 64, immediate 32, and immediate 8. And these functions basically call back to here. But right now I'm putting it in the right-sized field in a struct, which means that all the remaining bits of that field actually continue to be uninitialized. And if I want to make my job slightly easier for the rest of the constant folding business, it would be very helpful if I could always just access the 64-bit version, even if we are storing 32-bit value. Although for signed numbers, that's gonna be quite tricky. Yeah, actually, yeah, so forget what I said, it's not gonna work. I thought I would be able to do something like this. So I would say immediate 64 here, but actually that will do the wrong thing with signed numbers, because the way the signed numbers are represented in binary, like you would have for negative numbers, you would have like first, they are at 2 complements, so they have like 1 as the very first bit. And let's say I have like 8-bit number, right? So this is 8 bits. So this would be like minus minus 127 or something, or 128, I'm not sure. Anyway, the point is that if I have a longer number and then I just access like kind of a lower part of it, I would end up without the minus. So that's not gonna work. So what what I wanted to do actually is very stupid and I shouldn't be doing it. What I should be doing instead is just create another helper, and what that helper will do is to say operand immediate get value, or S64. We'll return as an S64, and if operand type, and here we just say 0, return 0, and assert expected in immediate operand. But now it's pretty straightforward. We just say operand immediate 8, operand immediate 32, and operand immediate 64. And C will do the conversion for us, so it will do sign extended move from this size to the S64. Okay, so let's just do that. And now we can say that we will do A S64 A S64 is operand as operand immediate as S64, and we just pass in a operand, and the same thing for the B. So like so. And now we need to do the same switch as we do here. So depending on operation, we will do different things. Okay, so we do this. And now we can say return value from immediate. I think that's called value from signed immediate. Yeah. This is going to be like this, and we just say A S64 plus B S64. That's all there is. And then we have minus. It's also like this. And we are done for this particular operation. Okay, let's try to run the tests and see if that all works. For now it does, and I want to go back to this test and remove this plus and try like this. So this should actually trigger our case, and we can verify that by just saying printf here, right? Maybe I should add a bit more of this stuff to know that we are actually here. And here we are. So we are actually dealing with this case, and we are no longer producing unnecessary assembly, which is very nice. Now the rest of it pretty much goes exactly as this one. So we just go through all the operations that we have and basically do this this stuff over here. I think I might even want to I probably want to extract this into a macro. It has to be macro because we are dealing with fundamental operations. So we have plus or minus. Unfortunately, in actually, I could probably abstract this away without a macro. Well, let's do that. So I say value star well, now I want a macro instead. And the reason I want a macro is because this needs to return, right? So let's say constant fold, or maybe constant fold. And we have A, we have B, and we do the following. So we have do while loop, and let's just say operand star A operand is like so. Yep, that sounds good. Then we have obviously B, and we take on this whole just over here and put it like so. Missing while 0, of course. So that's good. Slash 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 and more stuff. And let's end this and say maybe constant fold. And I also want an operator. So, this is actually a bit awkward now because this thing deals with both plus and minus. So I guess I have to extract this stuff to the top and do it here. I think I copied too much. Yes, I did. And now I can take this thing, put it over here, and here I'd say operator. Okay, here and here, here and here. Okay. So break, and I say maybe constant fold of A, B plus, and here it's going to be maybe constant fold of A, B minus. Let's try that again, and it still works, which is great. Just to know that I'm actually in the right place, I can switch it to minus to break it, and it broke, which is good news for me. Okay, I kind of like this, so that means that I can basically just take this thing, and we have multiply over here, and basically what I will do is I'll just say maybe constant fold, this is going to be x and y, and it's going to be multiply, and I have divide, right? So I do divide. This is in V. So I think yeah, this needs to be like that. Cool. Oops. Test. And we are good so far. So we have basic arithmetic arithmetic operations. The compare one is, well, I guess right now we have compare only for integers anyway. So it could be okay, although this is where things get a bit more hairy. So right now compare returns us what? It returns us a byte, I guess, right? So yes, it returns us a byte. Well, I guess I could make that happen as well. Let's do that. Basically the same jazz. We take the switch, we put it over to here, and we want to do what? Well, instead of these instructions, we say maybe well, let's try that. Maybe constant fold a b equal, not equal, less, and greater. I might have to change slightly how maybe constant fold works for this, so it guarantees to return byte, but I think the result of comparison will be a byte right away, but I'm not certain about that, so we'll see. Anyhow, this should not do anything to our stuff, and it does, so we can at least add that to the index. But the true test, if this actually worked correctly, would be when we get to an if. Where is the if? I think it is inside of a function h. So define if, have if builder, make if. So this is the tricky part. And the idea here is that if we know that the condition is false, then we can just not do any of the stuff that is inside of the if. And I guess I need to recheck what am I doing. So what is happening is that we get the label and we go here. So what we could do actually is say that label and this should not change anything right now, but it doesn't hurt to verify. But the idea is now if we return false from if, then this whole loop will not happen. And if this loop will not happen, that means that we will not generate any instructions inside of it, which is will be equivalent for removing this whole thing from the code. So that's should work just fine. We find some tests that has an if, and let's create actually a test. Testing for this stuff is a bit tricky. Like there is sort of nothing I can assert on pretty much. Let me think about it, because like the biggest hurdle always with tests is testing for something that is not there, and because it's not there, right? Okay, I guess what I can do is say if ik 1 and 0 to do test or checker value, I think we call them. Function type is void to S32. That's perfectly fine. Okay. We can call this and we can check that so I can do this. This should be just fine, but it doesn't actually test anything because we haven't changed, and it is not fine because we are trying to compare two immediates. Okay, that's actually okay because we need to fix that anyway. Like, we can go into here and say the following. I think I can't actually use this maybe constant fall here because we need to do it manually because we don't return the value anymore in case of make if we just not doing anything. So this is something a bit different from the original one. Anyhow, operand is immediate of value operand, and we basically say if operand is okay, let's start this. Operand immediate as 64 of value operand is 0. So if the condition is false, then we just return 0. Let me take this stuff and say a 64 value is this, and not value, but let's call it immediate. If immediate is 0, then return 0. Okay. Let's try on the test. Okay, at least we know that this stuff works because our test no longer crashes. But another way to verify that something is actually happening would be, first of all, I need to change this stuff. Should work, should correctly handle constant conditions. And one way I could actually verify that this stuff is working fine would be to go through the instructions here and verify that I don't have a compare instruction, right? So that would tell me that all of this actually worked. For this function, return function. Where are you? So it is function builder, it is ID. Okay, well, I guess since I have builder over here, I can do this check inside. So builder function builder, I think it is actually inside of here, yeah, function builder, we have array instructions. So this is what I can go through, and I can say that for u64 I is 0, I is less than dynamic array length of builder instructions. Plus I. And we now have instruction star instruction is dynamic array get of builder instructions and I can check that instruction what this instruction. Okay, this instruction mnemonic. Instruction mnemonic is not compare. It's illegal for structs. Okay. Well, let's just do this. No, that's not gonna work, maybe. What are we using for encoding anyway? Let me open this stuff up. So this is, yeah, we are actually copying all of this stuff. So I guess I'll have to do string compare. Well, that is fine. I can deal with that as well. Compare. Yes, it's dot, not stuff, and double equals 0. Yeah, they should not be equal. Let's try to run this. Okay, so at least we are good. So this is pretty cool now. It wasn't that hard to implement, and now if we have always false conditions, well, we just not gonna do anything for them. Now, in reality, it has a bit of an issue, because what this means that you can have totally invalid code in here, and the compiler would be like, well, it's never going to be executed, so it's perfectly fine. And this is an interesting design decision in general for the language. As far as I know, all compiled languages opt in to verify the program even if it is never executed. And honestly, I'm not sure which version is good. Like there's could be good arguments on both sides. On one hand, if you changing a constant to a non-constant value and suddenly half of your program falls apart because there was just some weird stuff going on, that's bad. On the other hand, again, if the tree falls in the forest and nobody's there to hear it, why bother to do stuff? Because that means that your compiler is going to be slower, because you have to verify all of the stuff that is actually not going to be used anyway. So like there is an interesting trade-off there to be had. Maybe a good compiler would allow person to choose what they want. I don't know. For now, I think this is perfectly fine if we never actually execute whatever is happening here. I think that's perfectly okay. One final thing I want to do with if in this case is that let me go back. Where was it? So we are here, right? There is an opposite of this, right? That if the condition is always false, it's always true, there is also no point in doing any kind of compare. And this means that we would just straight up go to the code, like, right? We don't need to, we wouldn't need this compare basically. And yeah, this compare is going to be unnecessary. So let's say bool is always true, and it starts off as false. And here we just say is always true is true. Basically, any value besides 0, we consider it as truthy, and that means that we can simplify all of this just to basically be just I mean, we do need a label, and we will need to resolve that label, but in reality there will be no instructions there. So let's see how our encoder actually handles this, because I'm not so sure it will be fine, but I guess we'll see. True. And before we do that, actually, let's figure out so here I will return -1, and here I would say if 1 is equal to 1, return 1. And I will still have this stuff over here. So this test will fail. In particular, it should fail here because right now we are not removing, we're not going to be removing this compare, right? So let's start with that. The test is failing. It's failing where I expect it to be, and it's all good. Now, it's actually something I want to mention, that I think it's a very good practice to, whenever you see the failure, to try to understand where the failure is without grabbing a debugger. And same for tests. When you're writing a test, you should expect the program to fail in a certain manner. And if it didn't, go back and try to understand why it failed in a different way than you expected, because otherwise you stop really understanding the system, and it becomes sort of a black box that you interact with, either through tests or through like adding stuff. And just, I think it's a good training for keeping this stuff in your head. Anyhow, so if we have this is always true, I can say if is always true. So if it is not always true, then I'm just gonna do this stuff. Is that correct? Going back to here, just want to check what function again does, actually what if does. So yeah, and then we just resolve this label. So that's fine. Let's see. Okay, yeah. I was worried that it wouldn't be happy with some stuff, but I guess it really wasn't. So now it's time to get the debugger, because we actually have a crash. Let's see where we are crashing. F5. It's perfectly fine. Access violation, reading location as 0. So that's kind of interesting. We have an instruction that doesn't have. Oh yeah, it actually doesn't have that. So what is happening is, where are you? Where are you? Here. We have this maybe label instructions, and they really don't have their name. So I just need to do if, like so. Okay, let's try that again. And we are good. So that's very, very nice. Now we have constant folding for plus, minus, multiplied, and divide. For signed numbers, we have it for equality and compares, and we even use it inside ifs to remove the branch that we are definitely taking, or remove compare. Remove compare from the branch that we are definitely going to take, or remove completely the body of always false branch, which is really, really neat. I think that's all I wanted to do for today. Thank you very much for watching, and hopefully see you next time.